In this lesson, I'm going to go over solving some quadratics in terms of geometric type problems. So in class, we're doing lots of practice on solving quadratics, especially with factoring. And you'll get a lot of practice with that to kind of solidify your work you did in Algebra 1 in 8th grade. But for this video, I'm going to focus on the last questions on this paper to make sure you know how to use quadratics in geometric settings, okay? So I'm going to actually kind of skip all of these. You can check out my key to make sure that you understand how to factor all of these to solve them. And I'm going to head to number 14. So I'm going to do 14 until the end for this video. Okay, so it asks us to find the variable x as well as two angle measures, ADB and DBC. So the first thing they tell us is that ABD is equal to x squared minus 8x. So x squared minus 8x. Then it says measure of angle DBC is the expression 6x minus 10. And the whole thing, right, this whole angle, so ABC, is equal to 110 degrees. So I'm going to set up an equation here and write x squared minus 8x plus 6x minus 10 has to be equal to 110 degrees. Now this is a quadratic equation because of that exponent of 2. So I'm going to get everything to one side, set it equal to 0 to try to factor it. So combining like terms gives me minus 2x. Then if I move this 110 over with subtraction, that will allow me to get it equal to 0. So x squared minus 2x minus 120 is equal to 0. All right, so I'm going to try to figure out, using my x, a times c that adds to b. So a is 1, c is negative 120. So when you multiply that, you get negative 120. b is negative 2. Can we think of two numbers that when we multiply them, we get negative 120, and when we add them together, we get negative 2? I'm thinking negative 12 and positive 10, right? That would multiply to negative 120 and add to a negative 2. So I'm going to factor this as x minus 12 and x plus 10. All right, getting my two factors equal to 0 will allow me to figure out my values for x. So I have positive 12 and negative 10. All right, now the other part of this asks us to find ADB and DBC, right? Those angle measures. So ADB is equal to x squared, this is the measure of angle, ADB. That's the same as x squared minus 8x. So I'm going to plug in the 12 squared minus 8 times 12. And that's going to give me 144 minus 96. All right, so 144 minus 96 is going to be, I believe that's going to be 48. Okay, then I'm going to find the measure of angle DBC using the same x value of 12. So 6 times 12 minus 10. So that's 72 minus 10, which is equal to 62. And I need both of those numbers, if this is going to work, both of these angle measures, right? Both of these angle measures have to add up to 110. So 62 degrees plus 48 degrees is 110. Is that a true statement? And it is. So 12 works. I'm going to do the same thing. I'm going to create a little room here. Move this over. So let me move it. There we go. Okay. Create a little room to plug in negative 10. So 12 worked. I tried 12. It worked. So plugging in negative 10 for angle ADB, right? Remember, this is x squared minus 8x. Plugging in negative 10 minus 8 times negative 10 is going to give me 100 plus 80, which is 180 degrees. Then angle DBC, sorry about that, DBC is 6x minus 10. That's 6 times negative 10 minus 10. That's going to be negative 60 minus 10, which is negative 70. Now, those numbers do add up to 110, all right, but we don't have a negative 70 degrees here right, these angles are going to be positive. So I'm going to say that this one does not work, right? It's called an extraneous solution. So just x equals 12, and then these two angle measures, all right, for ADB and DBC. That's 14. Okay, 15. 15 says CD is x minus 2. I notice this symbol is here, so that's also x minus 2. And the measure of angle BDC, so right here, is x squared minus 10. Now the first thing I notice with that is that it's a 90-degree angle. So x squared minus 10 is equal to 90 degrees. And to get this to be able to be factored, I'm going to move over the 90 with subtraction to get minus 100. Now this is a special case that hopefully you learned in Algebra 1. If not, you're hearing it here in geometry. We're going to hit this definitely hard in Algebra 2. You'll get it a lot. This is called the difference of two perfect squares, right? And it factors as the square root of the first one. So the square root of x squared is x. And then minus and plus the square root of the second piece. The square root of 100 is 10. And so those are the two factors. Setting these both equal to 0, I can find my two x values that I'm going to check to see if they work. So I get x equals 10 and x equals negative 10. All right, again, just like we did in number 14, I'm going to check to see if these work. All right, so I'm going to plug in negative 10. I'll try that one first. If you plug in negative 10 where it says x, you're going to get negative 12 for those two segments in their lengths, which we're not going to have a negative value for that. So this one is going to be incorrect, right? Let me actually use a different color. Another extraneous solution. Extraneous just means that when you did your work, it was a solution, but when you plug it back in, it doesn't give you a solution that makes sense. So let's see if 10 works, all right? So 10 minus 2, 10 minus 2, both of those are 8, and it wants us to find AC, which is the whole thing, right? So this whole thing is AC. So when you add those two together, you get 16. So the length of segment AC is 16 units. Okay, that's 15. Let's go to 16 through 18. Now, just so you know, as you look at this, on your paper, you only have this one image. I went ahead and copied and pasted it for 17 and 18 to help me show you my work. Just if you're wondering why you don't have it on. Okay, so we have C is parallel to D. All right, so this line T is a transversal. It wants us to find the value of each variable. So the first one says that angle 1 is 2 times x plus 40, and angle 7 is 11x plus 44. These are alternate exterior angles, which you guys hopefully remember from the first semester. They have that theorem, if lines are parallel, then alternate exterior angles are congruent. So I'm going to write 2 times x plus 40 equals 11x plus 44. So 2x plus 80 equals 11x plus 44. I'm going to subtract the 2x to the other side to give me 80 equals 9x plus 44. Subtract the 44 to give me 36 equals 9x. So x is equal to 4. Okay, so that's the value for x in this one. You can always check, you should always check to make sure that it works. So 2 times 4 plus 40 should be the same as 11 times 4 plus 44. Let's check that. 4 plus 40 is 44. 44 times 2 is 88. 11 times 4 is 44. Plus 44 is 88. So that checks out. You always want to check to make sure that you're going to have the right answer. Let's do 17. Okay, same thing, right? It's the same image. This time angle 3 is x squared plus 2x. And angle 7 is the opposite of x plus 70. All right, and these are corresponding angles. So if lines are parallel, then corresponding angles are congruent. So I'm going to set those equal to each other. X squared plus 2x equals the opposite of x plus 70. Now this is a quadratic equation, so I will be setting this equal to 0, getting everything to one side. Right? So if I move that minus x over with addition, that's 2x plus x gives me 3x. Move the 70 over and you get minus 70. Doing that same thing we did a couple problems ago. Set up the x. A is 1, C is negative 70. So when you multiply them, you get negative 70. B is 3. So I need two numbers that multiply to give me negative 70 and add to 3. So that's going to be 10 and negative 7. Okay? So because A is 1, I can go ahead and write those two factors. X plus 10 equals X minus 7. Getting my two factors equal to 0, I can find my solutions of negative 10 and positive 7. All right, plugging them in to check. All right, I'll plug in negative 10 first. So I have negative 10 squared plus 2 times negative 10 is equal to the opposite of negative 10 plus 70. So that's 100 minus 20 is 80. That's 10 plus 70 is 80. That works. All right, so this one works. Plugging in 7, I have 7 squared plus 2 times 7 equals the opposite of 7 plus 70. 49 plus 14, let's see, 50 plus 14 is 64. That's 63. The opposite of 7 is negative 7 plus 70 is also 63. That also works. So we have two values for x that would make this true. Okay, let's do the last one. We have 18. So same image. This time we have 4 different things they've given us. Wow, it's a lot. So angle 3 is x plus y. Angle 5 is 78 degrees. Angle 2 is x minus y. And angle 6 is 102 degrees. Okay, so you've got options here. You've got a couple of different things you could do. What I did to solve this was I first looked at angle 3 and angle 5 are alternate interior angles. So those are going to be congruent. So I did x plus y equals 78. And then I went ahead and did that angle 2 and angle 3 are going to be supplementary, right? They form a linear pair. So I did x minus y plus x plus y equals 180 degrees. So I'm going to leave this one alone for now. When I look at this one on the right, you'll notice that the minus y and the plus y, when you add this together, you get 0. So x plus x is 2x. So x is equal to 90. Okay, so now if I know what x is, I can replace this with 90 and solve for y. So y equals 78 minus 90, which is negative 12. Okay, now we can plug those back in to check if you want to. All right, so we need the x plus y equal to 78, which we know that's true. We got that y from there. And then we could also see is x minus y equal to one that we didn't use, and you might have used it on your paper, is x minus y should be equal to 102. All right, that's our corresponding angles. So if I plug in x is 90, y is negative 12, is this a true statement? 90 minus a negative is really adding. So 90 plus 12 is 102. That checks out. So here's x and here's y. All right. Again, I know I skipped a lot of problems earlier in the paper. I will have a key posted. You can check that out. But again, this is about using relationships that we learned in the first semester and your understanding of quadratics from Algebra 1 to kind of put them together to solve some geometric questions using some more difficult algebra. All right. Come see me if you have any questions. Good luck.